Good day, class. Today we're going to go over Unit 4, SAS 2, Recursion and Linear Functions. I find this unit very interesting because our world, or our technological world, works a lot off recursion functions. And you're going to be shocked to find out that you have very little experience when it comes to recursion functions. It's something that will be new for you, and it's actually a very interesting topic for me because I find it very useful. It's one of those items that when you start realizing that a lot of our technological appliances, like our phones and other items, work off recursion rules. Like an iPhone will stay on because there is a program running in the background saying stay on, stay on, stay on, stay on until something in there tells it to turn off or the screen to turn off. Or when you hit one of these icon buttons will all of a sudden automatically turn on a program because you're telling it that you want a new application. So now the screen you're on before now shut off, and now a new screen comes on and stays on until you give it a command. That's kind of how a recursion function works, and that's the way actually most computers work. Computers think in binary code like ones and zeros, so recursion functions come to it very naturally. When computer programmers think about recursion, they actually build most things in loops and rules, and that's how a computer understands it, and that's how kind of what a recursion function works like. A recursion function works with the idea that something's going to keep on working until you tell it to stop or it never stops. Now, what is the notation of recursion functions? It's a little different, and the reason being is because you pretty much can start anywhere and it carries a special type of notation. And we're going to discuss notation in much more detail, but we're going to go ahead and start in very simple terms. Now, you all see the sequence that's in front of you. I know most of you probably consider Mr. Sandoval as a very simple sequence. I learned that back when I was in kindergarten or even first grade. I would like to now relate it to recursions. What we're going to do is that we're going to go ahead and actually start kind of matching up those previous terms to the sequence so you can start getting an idea of how a recursion function works like. What I'm going to do now is I'm going to pause the video. I'm going to call on somebody randomly to kind of give me a starting point to the sequence. And the starting point is going to be, really, it could be chosen anywhere. That's the unique thing about a recursion rule, is it doesn't depend on X and Y. It really depends on a starting point and a rule. And what I want you to do now, what I'm going to do now is let me go ahead and pause the video, call somebody randomly to give me that starting point, and then this notation will become much more familiar with you. Now, we're going to go ahead and start building a rule. Now, in the to make it simpler and to understanding how the rule works, I'll go ahead and go step by step on how one term builds upon the other as far as our process of building a rule using the recursion notation. Now, I'll go through another example for us to go ahead and also see how to build a rule using function notation using a different sequence of numbers.